sandali at aking lalapitan. Kabilis kagad umalis at bigla kong naiwanan.
Tuwing umaga'y nakita, pagpasok sa eskwela, lahat sa kanya'y napapa.
Theorem 7 states that two lines perpendicular to the same plane are parallel, and conversely, if one of two parallel lines perpendicular to a plane, the other is also. For example, I have these two lines here which are both perpendicular to the same plane. Therefore, these two lines here are parallel to each other. That's a good question. A line is said to be perpendicular to a plane if it is perpendicular to every line passing through its foot. Remember, the foot of the line is the point in which the line meets a plane. This line is also perpendicular to this plane, which is the ground. As corollary to this theorem states that if a plane is perpendicular to each of two parallel lines, which is that line, then it is also perpendicular to the other, which is this line.
Parallel planes are two planes which do not meet. And if we will say a line parallel to a plane, this is a straight line and a plane which do not meet.
It states that if a line is parallel to a given plane, it is parallel to the intersection of any plane through it with a given line. Example, I have this straight line here, which is parallel to this plane. And therefore, we can say that this line is also parallel to the intersection of these two planes. Because it is stated in corollary 1 of this theorem that if a straight line is parallel to some line, which is this line in this plane, and therefore this line is also parallel to this plane. Theorem 9 states that if each of two planes is perpendicular to the same line, they are parallel. And conversely, if one of two parallel planes is perpendicular to a line, the other is also. For example, I have this ceiling here, which is my plane, and the floor, which is my another plane. And this pillar serves as my line. The ceiling and the floor are both perpendicular to this pillar. Therefore, they are parallel. Theorem then states that if a plane is parallel to each of two intersecting lines, it is parallel to the plane of these lines. Example, I have these two intersecting lines of that plane and I have this plane. If this plane, which is the floor, is parallel to the two intersecting lines, then this floor is also parallel to that plane. It's because, as we all know, theorem 2 states that a plane is determined by a line and a point that on it two parallel lines and two intersecting lines. In this case, the two intersecting lines determine a plane. Therefore, this floor is also parallel to that ceiling, which is our plane. Theorem 11 states that through a point not on a plane, there is one and only one plane parallel to this plane. I have an example here. Let us say that that point not on a plane and this floor is also the second plane. Then we can say that this floor is parallel to the ceiling. Theorem 12 states that to one of the two skew lines, there is one and only one plane parallel to the other line. I have an example here. Let us say that this line and this another line are called skew lines. Since skew lines, these two lines do not meet and are not parallel. say that if this line is parallel to some line of that plane, therefore we can say that this line is parallel also to the plane. And therefore we can conclude that through that squiggly line, there is one and only one plane parallel to the plane. Theorem 13 states that through a point outside of each two non-parallel lines, there is only one plane parallel to both of these lines. I have an example here. Let us say that these two lines are non-parallel lines. And through that point, we can say that there is only one plane, which is the ceiling, parallel to both of these lines. Theorem 14 states that if two intersecting lines in a plane parallel, respectively, to two intersecting lines in another plane, then these two planes are parallel, and the corresponding angles formed by these lines are equal. I have an example here. Obviously, that two intersecting lines determine a plane, which is the ceiling, and this another two intersecting line also determine the plane, which is the floor. So we can say that these two intersecting lines is parallel to the two intersecting lines. So therefore we can say that also this plane is parallel to that plane.
States that if two straight lines are cut by three parallel planes, then the separate segments of one line are proportional to the corresponding segments of the other. If we say intersecting segments, this is a segment formed when two planes meet through a straight line. For example, I have this one line here and another line here. They are cut by three parallel planes, and this is the intercepted segment formed, and it is proportional to the other segments.
The hedgehog angle is an angle formed by two half planes or two planes meeting in a common edge. For example, I have these two planes here which meet in a common edge. And this common edge is called the edge of the angle. And these two planes here are its faces.
States that two dihedral angles are equal if the plane angles are equal. And conversely, if two dihedral angles are equal, then their plane angles are equal. For example, I have these two planes here which meet in this common edge and they form a dihedral angle. And another two planes here which meet in this common edge and also form a dihedral angle. And I have this plane angle. Plane angle are two lines in their respective faces of a dihedral angle and perpendicular to its edge at a common point. Or simply, it is an angle formed between two intersecting planes. As you can see, this plane angle are both equal to these two dihedral angles. And therefore, these two dihedral angles are equal.
Theorem 17 states that if two planes are mutually perpendicular to each other, and if a line is drawn from a point in one perpendicular to their intersection, then this line is also perpendicular to the second plane. I have here the two planes, which is the first plane is the wall, and the second plane is the floor. These two planes are mutually perpendicular to each other. And when we say mutually perpendicular, These are two planes perpendicular to each other and form a right dihedral angle. And if a line is perpendicular to the line of intersection of these two planes, then we can conclude that this line also perpendicular to the second plane. Theorem 18 states that if a plane is perpendicular to each of two planes, then it is perpendicular to the line of intersection. I have these two walls here, which are the planes, and meeting in a line, which is their line of intersection. And if this floor is perpendicular to these two walls, then also this floor is also perpendicular to the line of intersection.